Okay, so most of you already are from data background, so that will be really quick for us to understand. So data types and DBMS we will understand about from the beginning. So for the people who are, not from data background, they can have like definition or, understanding of the data, what exactly the data is called in, in general terms, not for specifically for the Databricks. So in introduction, let me just here. Okay. So like everyone is familiar with the data. Data is like measurable quantities, anything which is like observation facts are called the data. And raw data information is like most important constituent that is, applied in analysis and decision making process and formation, development strategies, and numerous disciplines we can use the data. Okay, and as we all are familiar with relational database management system, it is, having integrity and having, like user defined integrity relations with the multiple tables, structures, and all those things. So it is helping to maintain the consistency in among the data. Okay. And as we know about the tables, we'll understand that how this is divided into rows and columns, and this is like, structured data. And we'll understand more about this. So here we have tables, how we are putting the tables, how we are keeping the columns, fields, attributes, keys, and records. So I hope everyone is familiar with this concept that the databases are having this structure. Okay. And SQL statements. So most of us are anyways familiar with the micro SQL or structure query language. So we can insert the record, we can search the record, we can update the record or delete the databases recorded using these statements like select, update, delete, insert into, and create, alter, etc. So these are some of the common commands we may use to manage our structured data. Okay. And now let's go further. So features of RDBMS. So as we have seen in the previous slide, that we maintain the record in rows and columns. So it maintains the consistency among the data, and data is totally structured. But nowadays, data structure is little bit changing and data type is also changing. So for analytical purpose, we require some tool, some sort of tool which can understand structured, non-structured, or semi-structured data. So we'll talk about this kind of data which are available nowadays and which has to be, worked upon, and should be, should have some sort of tool which can, consolidate these kind of data together and create some meaningful insights. So this is where, Databricks come in. Okay, so most popular databases as of 2022, like Oracle is 31% market share, MySQL is there, SQL Server is there, Microsoft Access. So largely the structured data is being maintained in these databases, and these databases are required to be, analyzed. For that we have several tools, but there are, data now gathered from IoT devices or social media or any other source which are mostly unstructured or semi-structured data. So that also has to be, combined with this data which we are able to fetch from here, and has to, we have to have some sort of tool which we can work with and combine this data and create some insights for the business so they can make some meaningful decision. Okay, so data is mostly divided into three categories. And structured data, first is the structured data, which we are familiar, that which is being maintained in the tables and rows. And this kind of data is easy to deal with. And this kind of data nowadays in the business world is 20% only. So if you see the structured data quantity is getting less and less, so it is around 20% only nowadays. Earlier, during the 90s and that time, it was almost 100%, which is like, to analyze, we could manage it with the any tool available, or ETL process we could use, and we can easily manipulate this data and make some insight out of it. But nowadays we have this data, which is the unstructured one or semi-structured one, which is increasing in the quantity and almost keeping it 80% of the data which has to be analyzed. So this is really challenging with the traditional tools of ETL process. And these are like huge amount of data, um, which requires some sort of a specialized tool which can work with the multiple nodes or multiple resources, compute resources. uh, but definitely without this data, if you use only this 20% data and produce some meaningful insight, it's really very difficult to uh, you know uh, make some insight which is really making any sense on that business. All right, so now let's go and see what is the structured. I think structured data, everyone understands that we are producing this structured data basically for business applications, or from the business applications, like we are using financial transactions or inventory or CRM or HR system, which are like in the tabular format, and these are having the relations or correlated tables, which can and data size is very less. So if you see the data footprint from the relational or the structured data is very less compared to other data. Okay, and now we will understand about what is the unstructured data, because we keep talking about structured and unstructured. So unstructured data is formed by different file formats. So that are in form of log files. For example, we may have log file, we may have sounds, images, and other raw data. So any data which is not having or following any structure or tabular format is called unstructured data. Okay, so uh, this form of data poses a major challenge to organizations because it is difficult to extract, because these are like data which are not following any pattern. So it is really difficult to extract this data and make some sense out of it. So this is called unstructured data. And managing such data means that storage space will hugely occupied. So one of the requirement by having this kind of data, and if we require to analyze this kind of data, is the storage space. We have to have sufficient storage space to keep this data somewhere and start analyzing, because structured data is already lying in the database system or data warehouse, where we can fetch the data and do the manipulation. But here we have data which is scattered across, or maybe multiple sources we may have, and we have to have some sort of storage space where we can keep this data and keep analyzing it. Okay, it cannot be described by data model or schema, so it doesn't follow any schema or data model. Therefore, it is difficult to analyze. Most databases can be managed, analyzed, and researched. Okay, so it is not so easy to analyze this kind of data and make some insight. Unstructured data includes information in textual. It can be maybe log files or some text file which are not having a regular pattern. It can be a collection of images, audios, videos, or any format it could be. And it is like qualitative data. We call it qualitative data because it is not a quantitative one. So structured data, we call it quantitative because we can maybe count it, we can measure it, So any quantitative analysis we can do on that, but these are the data which are mostly called qualitative because it cannot be measured. Okay. It is typically saved in NoSQL databases. As we know, in the database system, we have SQL database where we can run the structured query language. And by having the structured query language, we can uh, get some output using the query. But here we may be using the NoSQL databases or non-relational data store. So it could be the possibility where maybe unstructured data we are keeping as an object in NoSQL databases, or we may have a repo or data store where we are keeping all the files which we are collecting. Some of the human generated unstructured data are like text files, emails, social media posts. So these data types are some of the example which are unstructured, like mobile communication data and business applications. So these are some of the example which we may consider unstructured, and these are various or a few example having this data type. The machine generated unstructured data is like satellite images, for example, or data captured by scientific instruments or sensors. IoT devices nowadays very common in the market. So these are also generating some meaningful data which has to be analyzed, and a decision has to be around them, or video surveillance, etc. So these are some of the example of unstructured data. So same thing, text, email, images, audio files, video files, log files. It could be sensor data or social media, which doesn't follow any specific structure in common sense. Okay, so here we can see like uses of unstructured data. We may have social media, we may be using Twitter, Facebook, Instagram. So these all data are being produced by different platform, and they do not follow a standard format. So they are having their own form. So tweets are different, Facebook posts are different, Instagram posts are different. Their comments maybe, or maybe similar type of unstructured data. And uh, unstructured data and convert this social media data to structured data to understand consumer sentiments, trends. So what output we can get from this data is like we can make the sense of consumer sentiments or any trend which is being around, and the brand perception. So some of the output we can produce from this data are this kind of. Then image recognition. Image data is unstructured data applied in body identification, for example, facial identification or something like that, object recognition, and computer aided, services or medical imaging, any sophisticated methods or pattern recognition logic work in the pixel level by analyzing bits to solve problems as simple face recognition or as complex as object identification. So there are some of the use like face recognition we can go for, or if these are some security installation where maybe any object identification is required, or in medical terms we may use it for disease diagnosis like x-rays or any sort of imaging technology. If we are using in medical instrument like MRI and all those things, we may analyze it by this pattern. So using ML or AI, we may diagnose this or disease. Further, for text mining, we can use unstructured data. So, structured, semi-structured, and unstructured text from documents, emails, or web pages is extracted to identify key pieces of information. So sometimes text data is also important, which is like not having or not following any structure, but can give some sort of clue or some sort of idea about the brand and all those things. And uh, categorize a text as positive, or we may create some logic around, and where we can identify positive or negative or neutral sort of categories of the topics which is being written in the text. And then these simple natural processing methodology, NLP methodologies, are used in identification of patterns. So we can identify the patterns around, and identification of keywords we can use for from these data, and content summaries. Okay, so we can do the data mining using text files, or now uses of unstructured data like sensor data, where we can use like real-time information from both sensors or IoT devices. Nowadays, very common IoT devices which are producing a lot of data nowadays, and industrial equipment maybe. So some manufacturing plants, or some plants, some sort of plants, industrial plants, their equipments also nowadays producing a lot of data which is being generated, and these data are really important for the business nowadays. Uh, so subsequently, processed for the performance bottlenecks. So these are like, these data which is being produced from the machines or different devices can be used to, if we are facing any performance related issue, if we have any bottleneck with the specific equipment or, device which is producing the data, maybe some error logs or something we can see, or if any warning or any issue frequently generated on the plant having any specific machine or device, we can use their data to analyze the process, or any other issue. Through the analysis we can make some sense out of it, and information gathered from the sensors in terms of time series help in understanding the state of environment, the condition of operational tools, and overall process of manufacturing. So mostly in the manufacturing, we are using some sort of, or many sensors which are producing the data, but these are really important data, because these may indicate our efficiency or equipments which we are using in the plant, that how these plants or how these equipments working together, how efficient is our production procedure. Maybe some equipment is producing the warning or some sort of fatigue sign where it requires the maintenance or something. So operational data are equally important nowadays to make a business decision. Okay. Now, next type of data, which is the unstructured data, is video surveillance. So here we may have example like raw video data is applied in video monitors for security, observing behavior patterns, okay, and identifying the incident. So if incident related, we have frequent incidents or sort of some sort of, then we may use the video surveillance data and make correlate these incident with each other, or maybe we can use this data and we can combine with other collected data, and make some insight out of it. So facial recognition or algorithm perform video analytics on video feeds, and are capable of detecting motion, identifying objects or threats, notifying security agents. So these data can be helpful for notifying security agents for any suspicious activity happening around the plant, or so now, structured data versus unstructured data. So how these are being arranged, or what is the difference mainly we can talk about here. So here, this can be displayed in rows and columns, and it cannot be displayed in row and columns. So like not like a relational database, these are like file formats. Then this could be the example, like this may have the data types which are like numbers, dates, strings, this sort of data. But here we will have the images, audio, video, and word processing. So these data types, as you may have noticed, that these are totally different and require some sort of tool which work with these both kind of data. Now, the third is estimated, almost 20% of the, enterprise data, as per Gartner. And now it is getting less, because earlier it was having more share, but now it is estimated that 80% of enterprise data is unstructured one. So this quantity is really getting big. Earlier it was huge, but now it is getting the more and more share, and it is more useful to make any decision. And definitely there is huge weightage of to make a decision uh, in the business using the unstructured data. And definitely requires, because it is managed in rows and column, a tabular format. It is not having any high demand of storage compared to unstructured one. But unstructured one could be like videos or images or some sort of data which is being produced frequently, like log files, or so that requires a lot of storage. And easier to manage and protect with the legacy solution. So we can use like DBMS to manage this, securing these data is really easy compared to this one, because it is more difficult to manage and protect. With the legacy solution, we require some sort of a new solution which can manage this kind of data. So difference between structured data and unstructured data, we have detailed, comparison here. Like format, we have seen like tables and databases. We are managing structured one, but unstructured one, there is no format at all. Okay. And in schema, it follows the predefined schema, but there is no fixed schema. It's like flexible. In storage comparison, if we see, easy to store in databases or spreadsheets. But here, unstructured data is difficult to manage and require a specialized, storage solution. So as we go with this course, we will be looking at the storage solution, which is like Azure platform. We will be understanding about this, that how Azure stores this kind of data. Then the retrieval of the data is simple and straightforward, because we can use the SQL query or some sort of tool, and we can, easily, extract this data. But here it often requires advanced search algorithm and this to extract the data here. For analysis purpose, it well suited for quantitative analysis. So with the help of queries, we can analyze this data easily. But here we require specialized technique like natural language processing, etc. For processing, is easily processed during the traditional method or using the traditional method, but it requires advanced processing technique. Complexity point of view, low complexity compared to the unstructured one. It is because having a structure in place, but it is having high complexity due to lack of structure. So this is one of the challenge here. And the size perspective, we know this is very small size compared to this one, which is having the large due to multimedia content. Okay. Insights extraction, if we see, straightforward to extract insights, but here we require sophisticated analysis methods, where Databricks and this kind of tools are coming in place. Now, next is database management. We can use traditional DBMS system for this, and we can manage this data, but it requires maybe no SQL or any specialized DBMS. Searchability point of view, it is highly searchable using the SQL queries, but it is less searchable, often relies on metadata. Okay. And these are some of the examples, maybe structured data like CSV files, spreadsheets, or databases could be the example here, like text documents, email, images, and videos. Okay, now something which is falling in the between means it is having not rigid schema or pattern, but it is having some sort of, structure. So this kind of data is called semi-structured data. Okay, so semi-structured data is a type of data that is not purely structured, but also not completely unstructured. So something which is, in between, not structured and not fully unstructured. It contains some level of organization or structure. Okay, so little bit of organization or structure, but doesn't conform to rigid schema. Okay, so this is what we call the semi-structured data. Okay, or data model. So and may contain elements that are not easily categorized. So the challenge here is that we cannot categorize or classify these data in a standard format, but some sort of structure it maintains. Okay. Now, in the semi-structured data is typically, characterized by the use of metadata or tags. We may use metadata or tags to, identify or characterize this data that provide additional information about the data elements. Okay, semi-structured data is data that doesn't conform to a data model but has some structure. It lacks a fixed or rigid schema. It is the data that doesn't reside in a relational database, but that have some organizational properties that make it easier to analyze. Okay, so this is what the categorization of semi-structured data. Now, the characteristics of semi-structured data, we can see data doesn't conform to data model, but has some structure. Second characteristic is data cannot be stored in the form of rows and columns. Okay, so we cannot have, standard like row format and column format like tabular structure in databases. Semi-structured data contains tags. Okay, it maintains some sort of tag and elements. Okay, so it's called metadata. So combination of tags and elements called metadata, which is used to group data and describe how data is stored. Okay, so by using tags and element, we can describe this data and make some sense of out of it. So similar entities are grouped together and organized in hierarchy. Okay, this is one of the characteristic here. Entities in the same group may or may not have the same attributes. It may have, different attributes in entities, but entities are like identity for these data which we can refer to, and they may have different attributes. Each entity may have different attributes, but like something which is the entity will give you like row kind of feeling here, or the properties doesn't contain sufficient metadata, which makes automation or the management of data difficult. So because it is not having, it is not always basically having, the metadata which is like maintain or can be used for automation of the data. So this is a like one of difficulty here. Size and type of the same attributes in group may differ. Okay, and then due to the lack of well-defined structure, uh, it cannot it cannot used by computer programs easily, because computer programs cannot make sense out of these data, and someone has to intervene and make some sort of a relation between them. Now the sources of semi-structured data, like as we discussed, maybe it could be emails, it could be some sort of XML files, or markup language or binary executables, maybe TCP/IP packets or zipped files, integration of data from like different sources or web pages. So these are some of the sources where we may have semi-structured data, from. All right, so let's move forward. And these are some of the example like XML. If you see the XML format looks like this, where we can have like keys or entities, and with different entities you can create or produce the data. So like student list is there, and with each ID of the student, data starts and having maybe the same attribute or maybe the different attribute. Okay, so like data, maintain some sort of format in form of entities, but are having the list of attributes which can differ. Second, semi-structured data most commonly used is JSON, which is being used in most of the even IoT devices also produce the JSON files, or some sort of equipments also produce the JSON file, which are like having some similar format like XML, but having different pattern here. So here also you can see like beginning of JSON file, it is like array, and then colon. With the colon you can have key and value pair, and so like each key is having a value in front of it, and these are separated by comma from here. So these we can call attributes. Okay, and this is like entire object. So this curly braces, this one is having an object or a row you can call or something. So this confront like this. Here you can see like we have entity here. The same way this can be called as entity. And this again separated by the comma, where we may have the next similar entity. But the attributes again doesn't fall to rigid format. The next entity may have a common thing like employee ID, but may have some more attributes or less attribute depending on the that employee attributes or available properties. Okay. Now we have seen the structure and non-structured data and semi-structured data as well. So we understand about the data types or all the data types which we may have to analyze, or we require to analyze in using the Databricks or any tool. So this is like showing that little bit structured here, like rows and columns or specific schema. But unstructured one is not having any schema, but having the semi-structured one is having sort of entities. So let's say if this is a each column represent one entity. Each entity may have some difference in attributes, but at least some sort of formation is there. So this is called semi-structured one, mostly XML and JSON format. Now let's see what we call or what do we understand by the big data. So big data essentially is a set or collection of data. So big data is just a new terminology because it's like huge. So that's why it is used. But again, it is the set of, or collection of data only. It's nothing more, but the size is so large. That's it. So it's a collection of data. So large or complex data. Okay, that it cannot be processed through normal data processing methodologies. So we cannot use a simple methodology to, simply analyze these data. And the size of data is so large. And now let's see what the size it is talking about. So these data sets normally lies, or lie in between terabytes. So as a lot of data is being produced every year, it is like increasing. So we started with the terabytes, but now it is, increasing all the time. So terabyte unit of data storage, which is equal to 10 to power 12 bytes, and petabytes. So now we are going towards the petabytes, where the lot of data is being produced, and this is becoming like big data, which is 1,000 of times of this one. So even more. Big data analysis can be or can help uncover patterns and shifts. So um, big data analysis now is becoming more and more common, because we know that there is a lot of contribution of unstructured and semi-structured data, or data is being produced more frequently with the not having a proper structure in place. uh, so pattern and shift, as well as identify potential correlations, and especially those that concern human activity and relationships. So big data analysis is becoming more and more requirement nowadays. And some of the like parameters, or some of the properties, when we have big data we define. So first, it talks about huge amount of data. Okay, so this is what we refer to big data. And it is having, then second, when we call big data, is not having a single format. So it is having different formats of data from various different sources. So multiple sources, huge volume. Veracity means inconsistencies, uncertainty in data is veracity. And then the velocity of data means like sensors and these sort of data, or IoT devices. These are producing huge data, or data at a huge speed. So very high speed accumulation of data. This is one sort of thing which we can call like big data. So these are like, you can consider like properties why we call it big data. And when the value perspective, extract a useful data. So when we have these data with the high velocity, veracity, volume, and variety, but these data are important to collect and make a business decision. That's why it is called big data. Now we'll talk about some of the tools which are being used to analyze this kind of data, or in the market, which are available. So let's talk about let's say Hadoop, for example. So Apache Hadoop is an open source framework. So we'll talk about Hadoop. So let me go here. So Apache Hadoop is an open source framework that allows user to store and process large amount of data in parallel. Okay, so as we know, Hadoop is storing here and processing large amount of data. So this is one of the drawback here with the Hadoop as well. So it requires to store the data. But nowadays, data is like being produced frequently with the high speed, or different datas, which require a lot of storage. So this is one of the disadvantage with Hadoop, that it does require the data to store first. So basically, it will be taking it from the source, and it will store it somewhere. So there is like storage requirement, and then it can only analyze. Okay, so it can act on that data. Okay, then process large amount of data in parallel. How it works? Hadoop uses distributed storage, okay, and parallel processing. So this is like when we talk about Hadoop, it takes distributed storage and parallel processing to break down large workloads into smaller ones. So this is what the strategy Hadoop adopts, and work towards to analyze this data. Smaller ones that can be run simultaneously. So in parallel, it will work. It clusters multiple computers to analyze data. So Databricks will also be doing the same, and it will be also having a cluster and multiple computers or compute resource, which will be working together to analyze the data instead of using a single large computer. Okay, what it can do, so Hadoop can store and process structured, semi-structured, and unstructured data. It can handle virtually limitless concurrent tasks or jobs. So this is like Hadoop's capability here we are talking. And what it's used for, Hadoop is used in many industries like including finance, healthcare, security, and law enforcement. Okay. So now let's see how it's built. So Hadoop is built on Java basically, but other programming languages also support it, including C and Python and C++. So this is like the platform is built on Java, but it does support C, Python, and C++. And where it can be installed. So Hadoop can be installed on cloud servers, okay, Linux operating system agent or Unix OS agent or Windows OS agent. So it can be installed on maybe cloud servers, or maybe we can use it with the, if we have on-premise setup, which is now getting less and less. So it supports basically Linux, Unix or Windows. Some components of Hadoop includes, so Hadoop is having something called Yarn, a framework for job scheduling, and Yarn is being used for scheduling the job and cluster resource management. Okay, so it's like it will be managing your compute power, which tool is called Yarn, and then Hadoop map reduces there, a system that stores data on multiple sources. Okay, so basically, it will store the data on multiple sources for parallel processing of large amount of data. Okay, so that tool is called MapReduce in Hadoop. Okay, the next key tool in Hadoop is HDFS, a distributed file system that stores data in blocks. Okay, so it is a distributed file system and that stores the data in blocks, which are then often distributed across the cluster and replicated for safety. Okay, so it will offer the replication as well. In case of failure, it can have second copy available, and it is going to distribute to the cluster or among the clusters. So across the cluster, it will be used, and like in small chunks, it will be analyzed. So if we talk about a Hadoop architecture, it will look like this, where we can see that MapReduce, HDFS, Yarn, and Hadoop Common, they are working together. And like it is also having the almost same architecture like we are using in Databricks, but the storage is different. So here you can see we have master node, which is like controller, or it's going to manage our resources. And here we have master and slave setup, where the slave is like, the node which are actually processing this data with the help of map and MapReduce. So processing will be happening on the slave, and the master is like controller to the slave, which is going to manage the resources. Okay, now let's talk about another available tool, which is Snowflake. Okay, so Snowflake is a cloud-based data warehouse platform. Okay, that provides a single platform for data storage. Again, this platform provides like a single platform where you can store your data, integration, analytics, and more. So like here it is providing storage, integration, and analytics together. It's designed to help organizations manage and analyze large amounts of data efficiently. Okay. So this is one more tool which can help us to analyze the data. And here are some, some of the feature of Snowflake. So first feature is scalability. Okay, Snowflake can scale on demand to meet varying workloads. Decoupled architecture. So Snowflake's architecture is designed with three decoupled layers. So it is having three layers. First is storage layer, second is compute layer, and third is cloud services. Okay. Then it does support SQL. So Snowflake supports the most common standardized SQL version, enabling all common operations. Okay. Next feature is data flow platform. So Snowflake's data cloud is self-managed service that provide data storage. Okay, it's having its own, self-managed data cloud, and it provides the data storage, processing, and analytics solution. Okay. Now, a fifth feature is the multi-cloud strategy. Snowflake is available on AWS, Azure, and Google Cloud Platform, and supports a multi-cloud strategy. Okay, so it can work with the multi-cloud. Snowflake is built on Amazon Web Services, AWS basically, and Microsoft Azure infrastructure. Okay. So these are some of the features which are available with the Snowflake. And if we talk about the architecture, in VPC or virtual network, we can see this is like VPC, and in VPC we have like cloud services, one component, second component is query processing, and third component is a database storage. Okay, so these three components work together on Snowflake. So this is like architecture diagram. Okay, let me see where we stand right now. Okay, now let's talk about Databricks here. So Databricks is again a unified open analytics platform for building, deploying, and sharing and maintaining the enterprise grade data analytics and AI solution at scale. So it is like defined in this way that it manage or maintain the enterprise grade data analytics and AI solution at scale. The Databricks data intelligence platform integrates with the cloud storage and security in your cloud account. Okay, so it more talks about the integration rather than the having its own solution of storage and all those things. Okay, and manage and deploy cloud infrastructure on your behalf. Okay, so this is what briefly about the Databricks. And what Databricks is used for. Databricks provides tools that help you connect your sources. Okay, so we are not fetching it from the sources, we are connecting with the sources. So more like integration of data to one platform to process, store, share, analyze, model, and monetize data sets. Okay, so from the sources we can choose multiple sources, we can combine them, we can maybe use different sort of sources, structured, unstructured, and we can process that, we can store that, we can share that data, and we can analyze and we can model this data. Okay, with the solutions from BI to generative AI. Okay, the Databricks workspace provides a unified interface basically. Okay, and tools for most data tasks. Okay, including here, so we can see what workspace provides here: data processing, scheduling, and management. Okay, so workspace help us to perform like data processing here, scheduling, and the management of data, uh, basically like ETL process, and generating dashboards. So we can also create dashboards. We have feature in Databricks to create the dashboards. We can create the visualizations in the Databricks, where we can have the data visualized. Means we can create some charts or output of the data. We can in notebooks we can run the data and we can create some meaningful insight. We can generate some charts together, and maybe we can use this chart in the dashboard, so we can develop some dashboards from this data. And these visualizations and dashboard will be updated as our data is being processed and new data which is being analyzed. So as we process the data together, we will have more and more updated dashboards and visualization. Further, it will help. So basically, the Databricks workspace will manage the security, governance, high availability, and disaster recovery as well. So let me see. So security aspect is being managed by workspace. Governance is also being managed by the workspace. High availability means making sure that it is fail safe. Means if any failure occurs, still the resource is working, and it will make sure here. And DR part as well. So if anything happens with the our recovery or our main site, we should have another site where we can recover the process from there. Data discovery, annotation, and exploration also it will support. And ML, we can use the ML modeling here, tracking and model serving. And also for generative AI solutions also taken care into the workspace. Okay, now let's go to the next slide and we can have a brief comparison between Databricks and Snowflake. So let's talk about this. Okay, so in Databricks and Snowflake, if we simply compare, so service model here is platform as service in Databricks case, but in Snowflake, it is a software as service. So the difference, if you see here, is like if we talk about platform as service, so platform provides more control in your hand. Software as service is like subscription, okay, where you have less control on that one. And in platform, you have like you can manage the configuration, you can manage more aspect of it. So subscription example, for example, Microsoft 365 is an example of subscription where you can use the service, but you cannot control that service. Okay. Or platform as service, like you can have like example where you are managing the platform, for example, application service. So you have control to configure this application. Okay. So this is one of the example in AWS or Azure if we talk about. So a platform as service will give you more configuration rights compared to the software as service. So this is one of difference here. Major cloud platform support. So it supports Azure, it supports AWS, it supports the Google Cloud. In the Databricks case, here also it supports all the platform which Databricks supports. So it's like same. Again, the migration to platform, it is complex because it is a data lake. Okay, so because of the data lake where we store the data, migration is little bit difficult. Here it is easy because designed to based on the data warehousing. Okay, so that's the difference here. Scalability, it is having auto scaling. It is also having auto scaling up to 128 nodes. So there is some sort of limitation here. It will have auto scaling, but there is no limitation. So it can, have more, advantage. Vendor lock-in, there is no vendor lock-in here. But here we have, vendor lock-in because this is like subscription. So in that we may have the vendor lock-in. User friendliness here, learning curve, but here easy to adopt. So as we are learning here, we can have more friendliness here. But this is easy because it's like software as service and you can easily, adopt it. Data structures, it supports all data types basically, including raw data or audio, video, logs, text, etc. So everything it supports. It supports only semi-structured data, means JSON, XML, and all those things, and structured data. So unstructured data is not supported on the Snowflake. Okay. Now, service perspective, if we see, it is a big data, data science we can use, data analytics we can use it for, or ML purpose also we can use. So these sort of services are possible on this one. Uh, but here we have to have database management and data warehouse only. Data science and ML built in an unified tool for any type of development, here only available via third-party integrations. So this is dependency. And cost is like pay by uses, and here also pay by uses. Query interface, you can get SQL, Spark data frame, and Colas, and here only SQL is supported. Then query optimization, vectorization and cost-based optimization is there, and here also the same one. Provisioning of different type of nodes, yes, we can do, but here we cannot use the different kind of nodes. Okay. And there is no IPO, so this is like commercials, we don't need here, so it's okay. So this is like brief comparison between Snowflakes and Databricks. And I think for today, I think we talked, in detail about the data types, different tools which are being used in big analytics. We understood about the big analytics as well. So I think we have covered a lot of things today. And I think we will continue tomorrow. So if you have any question, maybe we can take and we can wrap this session.
Kamal, one question. Like
Yes.
provisioning of different types of nodes is yes
Mhm.
for Databricks and no for Snowflake. So what is that?
Yeah. Yeah. So here we can have, like node sizes, when we're talking about multiple node setup. So we may use, because this is like software as service, in
Mhm.
software as service we have, like subscription where we have less control on the nodes and all those things. But here we have, like we are using with the AWS or Azure, so we can choose our own sizes, that let's say how much RAM we are looking for, or what core, number of cores and all those things. So here we have more choices basically,
Got it.
compared to the Snowflake. Yeah.
Got it. Got it. Okay. Thank you.
All right. So all right, thank you everyone for today's session, and we can conclude today's session.